Thank you. Good morning, distinguished audience. I'm Sonia. I'm from Ecuador. I'm doing my PhD in the Universidad Politécnica de Valencia in Spain. The purpose of this presentation is to show a study that explored the newest technologies and possibilities of virtual reality in research for people with stereo-deficiencies. To know if the human adults could recover or acquire stereopsis in adulthood after trying using VR technology and devices, also contribute to a Spanish national project that developed systems to assess the spatial memory using different devices and technologies. The contents include these sections. First, introduction. In the introduction, I'll talk about the concepts and elements included in this work: stereopsis, 3D devices, 3D experiences. Stereopsis refers to the perception of depth through visual information that is obtained from the two eyes of an individual with typically development binocular vision. 3D devices. Since the appearance of the first head-mounted display development by Sutherland, many different commercial devices and no-commercial prototypes have been developed. Currently, there is different types of 3D devices to achieve immersion and interaction, such as a head-mounted display, caves, outer-stereoscopic displays. 3D experiences who didn't have stereopsis, didn't have perception of depth, when using VR devices, cannot enjoy 3D experiences, although they think that yes. After introduction, I'm going to speak about the objectives. The main objective of the study was development a maze navigation task to assess 3D experiences using VR devices for people with stereo-deficiencies. To carry out the main objective, we create a maze navigation task and we compare two different types of display systems between people who had and had not stereopsis. I'm going to describe of the maze navigation task. The Cincinnati water maze has been used commonly in studies with rodents. The maze consists of nine closed teeth. We create this virtual maze based on the Cincinnati water maze. It had a path of 10 intersections. The walls of the edge 2-meter high and 2-meter wide. A virtual bicycle was included as a first-person avatar from the participant's point of view to allow the participant to move around the maze. 4 animals were placed on the path at different positions to help participants to learn the path. For example, the butterfly was placed at the second intersection at the top of the wall. The snail was placed at the 4th intersection on the floor. Green directional arrow to guide the participant in the learning stage. Yellow double-headed arrow were created for the testing stage. I'll talk later about the stage of the task. This is a general scheme of a virtual task, a set of modules and functions with development in order to manage the devices, the communication between them, of input and output data such as time, attempt, head turn, and so on. We use Visual C++, C#, Unity, and Oculus plugins. This is a view of the virtual maze using the head-mounted display. This was our testing room for the largest stereo screen condition. This shows the participant on the left. We can see a participant carry out the test with a head-mounted display condition. On the right, we can see carrying out the test with a large stereo screen condition. Next, I describe the procedure and study. Before each session, all the participants filled out the personal data questionnaire and signed informed consent. Afterward, they were checked for stereopsis using the lunch stereo test card 1. The participants were divided into groups for conditions. Finally, when finished the complete questionnaire and previous experiences and presence questionnaire to know their perception about intersection, 3D sensations, and satisfaction. There, 3 stages had a maze navigation task. The habituation stage had a path of 4 intersections, and it allowed participants to familiarize with the virtual maze and the use head-mounted display. Learning stage had a path of 10 intersections. And the path was different to the habituation stage. This stage had green directional arrows to guide the participants from the beginning to the end of the maze. While they are learning to the path. The testing stage had the same path as the learning stage, 10 intersections, but yellow double had arrows. These arrows only appear at each intersection and disappear when the participant chooses a path. Then appear again when they are chosen to the next intersection. Each participant has 5 attempts to reach the end of the maze. The task ended if the participant reaches the end of the maze or if the participant uses up the 5 attempts. In total, the participants were 59. For large stereo screen condition were 29 participants. No stereopsis in this condition were 7 participants. For head-mounted display condition were 30 participants and no stereopsis were 8 participants. The main measure of performance of the maze navigation task were the score is the number of correct direction chosen in each of the 5 attempts allowed in the testing stage. Time, attempts, and head turn. Other types measures were a stereo test of lunge to determine which participants had stereopsis and which one did not. A participant passed the test when she or he had 3 of 3 positive responses. A participant failed the test when she had 3 of 3 negative responses. Also, we used 2 questionnaires, one about previous experience and another questionnaire to know their perception, interaction, 3D sensations, and satisfactions. Our results. The results of the performance on the task didn't show a statistically significant difference between both conditions for the 2 groups of participants. The results about interaction show statistically significant differences between both conditions. The results were obtained for the 2 groups of participant stereopsis and no stereopsis. Their differences were in favor of the head-mounted display condition. Therefore, the participants perceived the mechanism which controlled movement through the environment to be more natural. For the satisfaction in the second question, the results showed that there were statistically significant differences between the 2 conditions in favor to the head-mounted display. This means that in general the participant had a more satisfying experience using the head-mounted display. In the third question, the results are similar in favor of the head-mounted display. This means that in general the participant had a more satisfying experience using the head-mounted display. Overall, the head-mounted display allowed the participant to feel a more enhanced experience than the large stereo screen for the 2 groups, stereopsis versus no stereopsis. Finally, our conclusion future work are, based on our objectives, we were able to compare 2 different display systems between people who had and had not stereopsis, based on the same virtual task and the same device or interaction. The results showed that there were no statistically significant difference in the performance on the task between the participants with stereopsis and the participants without stereopsis. Participants who didn't have stereopsis and cannot perceive 3D when looking at the lunge stereo test or using other VR systems such as CAVE, large stereo screen, or stereoscopic display. However, they do have the sensation of depth when using the head-mounted display Oculus Rift DK2. The results suggest that for the people who didn't have stereopsis, the head tracking largely influenced the 3D experiences because stereoblind individuals rely more heavily on motion-based quest for depth. Our studies support the potential of current head-mounted display to help people without stereopsis to have rich 3D experiences. We hope to help people who are afflicted with stereo-deficiencies to have rich 3D experiences in VR with the work and ideas present in our paper. The Oculus Rift, other head-mounted display or other 3D displays technology could be used to design VR environment for training and to facilitate recovery of stereo vision by people with stereo-deficiencies. Thank you.
Absolutely perfect timing. Thank you, Sonia. So, do we have questions? If you'd like to come to the front, if you'd like to ask a question, or we can take the mic. I have a question to start off with. How many people don't have stereopsis, and what causes the lack of stereopsis?
In previous works, I read is approximately 10% of the people don't have stereopsis. In many occasions, the people, I don't know, has a good perception of field. In the research, we have experience with one participant say with me, "Oh my God, it's the first time I can see the object. I can describe a color, form, shapes in different characteristics." This is observation was interesting for our study.
Yep. Many years ago, I taught first-year psychology students, hundreds of them. There were 750 students in each year of students, so I mean literally hundreds of them. And they were about 30% were people in their 30s and 40s, and the rest were 18-year-old students. And we did stereopsis as part of introductory psychology, and we had a test. I'm not sure whether it's the same test you used, but if you have stereopsis, you see a giant fly. The fly is about this big. So you know when someone has stereopsis because they look and they go, ugh!
Yes.
But I was always amazed that each year we found quite a few people who would look and say, well, there's nothing there. And they didn't realize that they didn't have stereopsis, which for things like driving, it's quite important to know that you don't have. But I can't remember what causes it. Why do 10% of people not see in stereo? Can you give any information about that?
Is for the formation in the brain. It's a problem in the first 10 years in the childhood. It's possible in the after 10 years no finish the
the connections
in the brain, the connections for the stereo vision.
And do people typically have other symptoms? Are there other problems associated?
No, the people always is, oh, I can see, yes, always.
Good. Any other questions? Sorry, I'm getting into an interesting dialogue because I have very happy memories of scaring people with giant flies. Okay, so thank you very much, Sonia, for a very interesting piece of research and very good timing.